Find the exact value of all 6 trigonometric functions evaluated at theta if tangent of theta equals -3/7 and sine of theta is greater than 0. Well, we're going to do exactly that. I'm actually going to do it twice. I'm going to solve this problem 2 different ways using 2 different methods, because it's always nice to have more than one strategy to solve a problem. First off, in either approach, I'm going to identify the quadrant theta's in. I know sine has to be positive, and sine's only positive in quadrants 1 and 2. All of my trig functions are positive in quadrant 1, and since tangent's negative over here, that means I have to be over in quadrant number 2. So I think about that big angle over here in the second quadrant, this obtuse angle. Well, I'm thinking about it as obtuse. It might be coterminal with that. Regardless, the reference angle theta bar is a positive acute angle. So I could imagine that angle living in a right triangle. And I know tangent of that reference angle has to be 3/7 because my trig functions evaluated at a reference angle can only be different by a sine and nothing else. So tangent is opposite over adjacent, and now I can find that missing side, the hypotenuse. So the hypotenuse squared is equal to 49 plus 9, which is 58. And now h has to be the square root of 58. Well, if I think about 58, if I try to divide that by 2, I'm going to get 29. So there's no perfect square to take out from under the radical. So that's the best I can do. And now I'm ready to find the exact value of all 6 trigonometric functions evaluated at the angle theta. Because that right triangle, which I can think of as a reference triangle, will do the job for me. As long as I remember the angle I'm actually dealing with is in quadrant number 2, where sine and its reciprocal are positive and every other trig function would be negative. Now, I should get tangent right no matter what, and its reciprocal cotangent, because those are basically given to me. Now for the rest, I can just use this triangle. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And now all I have to do is take some reciprocals. And there I have it, the exact values of all 6 trigonometric functions evaluated at theta. All right, so we've done it. Everything seems nice and complete, but I told you I was going to do this problem 2 times using 2 different methods. So this time, instead of using a reference angle and a reference triangle, I'm going to use a Pythagorean identity. See, I happen to know that 1 plus tangent squared theta is equal to secant squared theta. Since I know tangent, I can write down that 1 plus minus 3/7 squared has to be the value of secant squared. I'm going to simplify this side. 1 plus 9 over 49 is equal to secant squared theta. And then finally, I'd have 49 plus 9 all over 49, right? Thinking about a common denominator there. And right, this is seeming familiar, right? 49 and 9, 49 and 9. I'm seeing the same things kind of happen. I end up with 58 out of 49 is secant. Take a square root, and just for a moment, I do need to think about a plus or minus being out front. Because when we solve an equation by taking a square root, it might be the plus, it might be the minus. And in this case, it's not both, or excuse me, it can't be just whichever one we want it to be. We have to have the one that matches the angle being in quadrant number 2. And in quadrant number 2, secant is negative. And look, we've settled on the same information that we knew over here. Well, now I know enough information, I think, to write all 6 values down again, having used a Pythagorean identity. Well, again, if I get tangent wrong, I guess I'm not working hard enough. Secant, I now know as being minus root 58 over 7, which means I know cosine, minus 7 over root 58. Now I just need to figure out what sine and cosecant are. Well, I'm going to kind of think about it like this. See, I know that sine over cosine has to give me this value of tangent. So I need that 3 over 7, so it's going to have to be a minus 3, because a negative 3 over a negative 7 will it needs to be a positive 3 because I'm in the second quadrant, and a positive over a negative is a negative. We'll just pretend that didn't happen. And I need this one to also be over root 58 so that when I do the division, the over root 58s cancel. And there I have it. The exact value of all 6 trigonometric functions with this given information 2 different ways.